Hello, this is Mr. Best. Welcome to Chapter 7, Homework Questions 131 to 137. Question 131. Tomika remembers that the diagonals of a rhombus are perpendicular to each other. Part A, graph ABCD on the coordinate plane below, and then is ABCD a rhombus? So let's go ahead and plot and see what we get. Alright, so we graphed the points. We need to find the distance of all four sides to see that they are the same. And we do that by finding a right triangle and using the Pythagorean theorem. So this side is 2, this side is 5. And I can calculate that, but I can really just look at the rest of them. As long as each right triangle has a length of 2 and 5, I know that they're going to be the same distance. And so as I'm measuring here, each one of these so far has a length of 2 and 5, and they all do. So without actually calculating it, I can already tell you that, yes, it is a rhombus, and I know that because all four lengths are the same side, even though I don't know what they are currently, but we can figure them out by doing 2 squared plus 5 squared is equal to that third side of the hypotenuse square, so 4 plus 25. And then the square root. So all four sides have a length of the square root of 29, and that's what makes it a rhombus. Part B, find the equations of the line on which the diagonals lie. That is, find the equations AC and BD. So we're looking for these lines AC and line BD. So we need slope and y-intercept. We can always take 2 points and algebraically figure that out. I kind of got a mess on my graph right now, so it's hard to see anything else, but I'm looking for the equation for AC. So point A is 1, 4, and point C is 4, 1. So we need to find the slope, and you can do that on your coordinate plane as well. You can look for the slope. It looks like you're going to go, for C, we're going to go 1, 2, 3 down and 3 over. So it does appear that our slope is -1. You can also use your slope formula, change of y over change of x, so that's 3 over -3, which is -1, so that matches up. And then the y-intercept, once again, we could work backwards, and if I didn't have so much stuff on my graph, maybe you could see it, but if I work backwards, my y-intercept is going to go up 1 to the left 1, and then that would give me a y-intercept of 5. At least that's what it appears to be. Once again, if you want to find out for sure algebraically, you can use your equation y equals mx plus b and plug in a point. I'll just use the first point. So 4 is equal to your slope times x plus b. So 4 is equal to -1 plus b. Add 1 to the other side, and you see that you get 5. So you can use the graph. If things work out nicely, you'll be able to figure out the equation without too much hassle. Y is equal to -1x or -x plus 5, and this is for line AC. But if things don't work out nice or they don't connect nicely, then you probably will have to use some algebra. We still need to find the equation for BD, so I'm going to do the same thing. So I went ahead and just did the algebra, and then you can kind of look at it, but it's the same thing as we did for line AC. This one has a y-intercept of 0, 0. You can kind of see that on the graph here, but I went ahead and calculated it just to make sure, and then I found the slope to be 1. So there's the equation for line BD. Now C says compare the slopes of line AC and line BD. What do you notice? Well, when we look at the slopes for AC, so line AC has a slope of -1, and line BD has a slope of 1. And so what do you notice? Well, they're opposite of each other. Now, whether this part comes into play or not, since they're 1 and -1, for lines to be perpendicular to each other, they need to be opposite and reciprocal. But the reciprocal of 1 is 1, so it doesn't actually change. But because they are opposite reciprocal, the diagonals are perpendicular. So therefore, BD is perpendicular to line AC. And I just want to make sure that I'm clear. It's because, not that they are just opposite. They have to be opposite and reciprocal. So this is opposite but they also have to be reciprocals of each other. Question 132. Find another valid logical order for the statements for Penn's proof from problem 7-113. Explain how you know that changing the order the way you did does not affect the logic. So I pulled up the question again, and if you take a look, the reasons aren't on here, but as you go through, the big thing that we had talked about before is that A and B on this one are congruent because alternate interior angles. B and C are congruent because of corresponding angles, so these two can be switched around. Those don't have to go in any specific order. But at A equals C on line 4, those have to be, that has to follow 2 and 3. So this one has to stay because that's the given. This one has to stay because that's the proof. And then this one has to stay because it has to follow 2 and 3. So these two, 2 and 3, doesn't matter the order that you put them in, but 4 has to follow it. And then 5 is C is equal to D. And once again, C is equal to D. Those are vertical angles. You could technically put 2, 3, and 5 in any order because you can say C is equal to D because of vertical angles. You're just not going to use it until the end at line 6. So I would really say 2 and 3 are the two that you can move around. You can switch those, but really 1, 4, and 6 need to stay. And then 5 technically could be switched around, but it doesn't really make sense to put it up there with 2 and 3. Or maybe, I guess in my opinion it doesn't, but you really could put 2, 3, and 5 in any of those orders after 1. 133. Each of these number lines shows a segment in bold. Find the midpoint of the segment in bold. Note the diagrams are not drawn to scale. So in part A, what's the midpoint between 3 and 9? Well, the distance between 3 and 9 is 6. So 9 minus 3 is 6. And then if we take half of that, we get 3. So we just want to go 3 this way, which would be 6, and another 3 would be 9. So your midpoint would be 6. Negative 1 and 7. So 7 minus negative 1 is 8, if you're not sure that the distance between negative 1 and 7 is 8. 8 divided by 2 is 4. So if you add 4 to negative 1, you will get to 3. If you add 4 to 3, you get 7. Negative 15 and 2, so that difference would be 17. Once again, you can take 2 minus negative 15 to figure that out. And that's 17. 17 divided by 2 is 8.5. So if I add 8.5 to negative 17, or negative 15, sorry, that's negative 6.5. And then if you add 8.5 to that, you're going to get 2. So those are the midpoints of each of those line segments. Question 134. Examine the diagram at right. Are the triangles in this diagram similar? If they are, use a flow chart with justifications or a 2-column proof to prove similarity. If they are not similar, explain why not. So let's take a look. Are the triangles, which would be this smaller triangle compared to the bigger triangle, are they similar? Well, we have angle F, which is congruent to itself because that shares the same one. We have this side length of FG compared to this whole thing. So because this is a mid-segment bisector, these two sides are the same. So it does cut it in half, which means its ratio would be 1 to 2. And the same thing happens on this side. You have this length over this full length, and so once again that's 1 to 2. So yes, they would be similar because you have corresponding sides in proportion, and then an angle and another corresponding side. So let's go ahead and do a flowchart proof for this. Alright, so there is the flowchart proof, and once again you can do a flowchart or a 2-column proof. I just chose the flowchart. It gives me the 3 things I need. Corresponding side, ratio is 1/2, the congruent angle, which is the reflexive property, and then another corresponding sides in proportion, which is 1/2 again. And that's because GH is the mid-segment. It breaks that side into 2 equal parts. So we know that the triangles are similar by side, angle, side. Part B. Name all pairs of congruent angles in this diagram. So since the triangles are similar, then we know their corresponding angles are congruent. So FGH and FIJ are congruent. And then we also know FHG and FJI are also congruent. So let's just go ahead and write those down. We have angle FGH is congruent to angle FIJ. And we also have angle FHG congruent to angle FJI. All right, part C. Are line segment GH and line segment IJ parallel? So GH and IJ parallel. And the answer to that question is yes, they are. Because their corresponding angles are congruent. And since their corresponding angles are congruent, we know that the lines are parallel. And another possibility, if you remember the triangle mid-segment theorem, if you go back and look at it, it does say, in terms of these lines, would also be parallel because of that. So that's another way that we can say that. All right, D. If GH has a measure of 4x minus 3, and IJ has a measure of 3x plus 14, find x, and then find the length of GH. So we know since the proportion is 1/2, we know that 2 times GH is equal to IJ. So therefore, 2 times 4x minus 3 is equal to 3x plus 14. 8x minus 6 equals 3x plus 14. Subtract 3x, add 6. And therefore, it looks like x is going to be equal to 4. But it also wants us to find GH, so if we plug 4 into 4x minus 3, 4 times 4 minus 3, 16 minus 3 is 13. So GH has a distance of 13 units. Question 135. Consider triangle ABC with vertices A, B, and C. We're going to go ahead and draw it on the graph paper, the coordinate plane, and then what kind of triangle is it? We got to prove why. So I've drawn the triangle. It appears that it might be a right triangle. So let's go ahead and see if we can prove that it's a right triangle by finding the slope of line segment AB and finding the slope of line segment AC. So if we find, and once again, we can use the coordinate plane and just graph. I'm going to go ahead and calculate. AB, it'd be 6 minus 3 over 6 minus 2. So that will be 3/4. And then for AC, that's going to be 3 minus negative 5, 2 minus, 8. So 3 minus negative 5 is positive 8. 2 minus 8 is negative 6. That reduces by 2 to negative 4/3. So for this AB to be perpendicular to AC, we need opposite reciprocals. So is 3/4 and negative 4/3 opposite each other? Yes. And are they reciprocals? Yes. So therefore, we do know that this is a right triangle. We know that line segment AB is perpendicular to line segment AC. So we know that's a right triangle now. And then part B, it wants us to reflect the triangle across AC. Find the location of B prime. What name best describes the resulting figure? So we're going to take the triangle, we're going to reflect it over. So I'm just going to take, the slope that we have here, which is up 3 and over 4, and just go the other direction with it so we can figure out where that B value is. And so if I do that, that looks like I'll go over 4 and down 3 to reflect that. And that looks like it'll be at negative 2, 0. So B prime will be at negative 2, 0. And then I can just connect here. So there's B prime. And then if I reflect it, then it's just going to go back over to C. And so now that means these side lengths are the same. All right, it also means that these side lengths are the same. So what kind of triangle would describe that? Well, it looks like we have an isosceles triangle because we know, excuse me, that this length over here, this length right here is congruent to this one by reflection. So we do know it's an isosceles triangle. And I think that answers question B in terms of proving your claim because we reflect it and BC is congruent. Line segment BC is congruent to line segment B prime C prime. Question 136. This problem is a checkpoint for solving with trigonometric ratios in the Pythagorean theorem. It will be referred to as checkpoint 7. So at this point, we should be getting really comfortable with our trig ratios in the Pythagorean theorem. So in part A, it wants us to compute the perimeter. We have all of it except for this length right here, but we can create a line that has a length of 5 because that's the same as this one over here. And then this is 5, so that means this is 5, which leaves 3 feet left on this side. So we can go ahead and use Pythagorean theorem. 3 squared plus 5 squared is equal to x squared. Don't get this confused with the Pythagorean triple because 5 represents the leg, not the hypotenuse. Pythagorean triple, it's 3, 4, 5, 3 being the leg, 4 being the leg, and 5 being the hypotenuse. So that was not the case on this one. So it looks like we're going to get 34 is equal to x squared, or x is equal to the square root of 34. And you can plug that in your calculator to get an approximation as well. And that would be approximately 5.83 feet. The question wants to know what the perimeter is, though, so we're going to work our way around. We have 5 plus 5 plus 8 plus 5.83, and so therefore the perimeter will approximately be 23.83 feet. Part B, solve for x. We have a right triangle. We are missing one of the legs. We have the other leg, and we have an angle measure, so we're going to have to use our trig ratios. With the 35 degrees, x represents the opposite. It's across from that angle, and the 10 is the adjacent leg. So you have an opposite leg and adjacent leg. We don't know anything about the hypotenuse, and we're not looking for it, so we won't use that. So therefore, that means we're going to use the tangent ratio. Tangent ratio is opposite over adjacent. So that's tangent of 35 degrees is equal to x over 10. You can just multiply both sides by 10, so that would be 10 times tangent of 35 degrees. Make sure your calculator is in degree mode before typing that in. And x is approximately 7.00, and this is measured in yards. All right, moving on up here, we have C, solve for x. So once again, we have a right triangle. We have an adjacent leg, and 150 represents the hypotenuse, and we're looking for the angle measure. So we are going to use adjacent hypotenuse, which is cosine. So we have cosine of x is equal to 60 over 150. And since we're looking for the angle measure, we are going to have to use the inverse. So we'll do the inverse of cosine of 60 over 150, and that will equal the angle measure. So on this one, anytime you're looking for the angle measure, you're working backwards, so you want to use the inverse of that trig function. And so therefore, on this one, x will be approximately 66.42 degrees. Part D, Juanito is flying a kite at the park and realizes that all 500 feet of string are out. Margie measures the angle of the string with the ground using her clinometer and finds it to be 42 degrees. How high is Juanita's kite above the ground? Draw a diagram and use the appropriate trig ratio. So let's go back through that information and go ahead and set up the figure so we can see what it is we're looking for and what trig ratio we possibly might need. So Juanita's flying the kite at the park and realizes that all 500 feet of string are out. So let's go with, here's the ground. I think they're just going with the ground. So we'll say from here to here is 500. Margie measures the angle of the string with the ground. So with the ground, that's 42 degrees. And then we're trying to figure out how high the kite is above the ground. So based on that information, it looks like we will be using opposite and hypotenuse with an angle, so that would be sine, so that'll give us sine of 42 degrees is equal to h over 500. You can multiply by 500, that'll be 500 sine of 42 degrees is equal to h. Plug that into your calculator, and you get a value of 334 point approximately 57 feet. So the height is approximately 334.57 feet. So that's the height of the kite. And so once again, this is a checkpoint, and that does mean that you should be coming very close in terms of having mastered these skills of Pythagorean theorem and your trig ratios of right triangles. Question 137. Must be, could be. Here are some more challenges from Mr. Quincy. For each description of a quadrilateral below, say what special type the quadrilateral must be or what special type the quadrilateral could be. Look out. Some descriptions may have no must be statements, and some descriptions may have could, and some descriptions may have many could statements. All right. Part A. My quadrilateral has a pair of equal sides and a pair of parallel sides. So in this one, you might be thinking that it must be a parallelogram, but it actually also could be an isosceles trapezoid. So you do have the option of the trapezoid or the parallelogram. So there is no must be's on this one. These are all could be's. And so once again, it could be a trapezoid, but it would have to be an isosceles trapezoid. It could also be a parallelogram. And then kind of going down from there, you could be a rhombus then, a rectangle, or either a square. So a lot of could be's on that one, but no musts. B, the diagonals of my quadrilateral bisect each other. So they bisect each other. So it must be, you might need to go to your toolkit, but it must be a parallelogram. So all parallelograms, diagonals bisect each other. And then from there, though, even though it must be a parallelogram, it could be either a rhombus, a rectangle, or a square. So it just depends on what the other properties hold. So a rhombus, rectangle, or the square.